Hidden inside your copy of Minecraft are the developer tools that Mojang uses to make the game. You've never seen them because Mojang disables them on purpose. I'm talking whole sections of code that are missing. But that's alright, there's enough breadcrumbs lying around for me to make a mod to bring these tools back to life and show you what Minecraft looks like for a Mojang developer. There's 4 different types of developer tools that I'll be showing you: commands, unit testing, F3 key combos, and debug renderers. So let's start off with hidden commands. There's 8 of them, though one only works on servers, so I'll be showing you 7. Turns out unlocking them is trivial. I'll show you the code. Yeah, so Minecraft's code has one value which, if enabled, does 2 things. It gives us these developer commands and makes the game log more info. Of course, we don't really care about the latter, it's the commands we're after. I'll quickly go over the commands that don't really seem to work. There's debug path, which requires the source to be a mob. If I run it as this pig, it says it made a path, but it doesn't really do anything. There's also debug spawning, which takes a spawn group and some coordinates, but this doesn't even say anything in the chat. And I've tested different spawn groups in different conditions, it really doesn't seem to do anything. The next 2 commands originally didn't work, but I managed to find the issues in their code and fix them. There's spawn armor trims, which literally spawns all the different combinations of armor trims on armor. Before I fixed it, all these armor stands did not have armor because Mojang changed the way the material of armor works, but they did not properly update this command to go with it. It also spawned an empty armor stand for armadillo armor because armadillo is a new armor material with the armored paws drop. But of course there's no armadillo helmet or chestplate or leggings or boots, so they were just empty. I would love to take the time to explore all this, but it makes my game nearly unplayable with the lag. Next up is the server pack command, where I can use push to add and pop to remove a server resource pack. It needs the URL of a resource pack file, so in this case I'll give it the bare bones zip file, and if I press enter you can see I'm prompted for a resource pack, and if I click yes it's gonna download it. And just like that, I've downloaded the bare bones pack. And if I disconnect, it gets rid of it. I'm interested to see what would happen if this was enabled by default. Like imagine adventure maps where you do something that triggers a resource pack to be installed. That'd be so cool. The last 3 commands worked out of the box. In order to summon the warden, you need to activate a natural 𝚂𝚘𝚋𝚘𝚙 4 times. That was the first time I activated it, and if I use this command, I can see that my warning level is 1. I've triggered it so I could reach level 3, and now when I step on it, I'm at level 4. And the warden should spawn. There we go. So for some reason, there is a warden spawn tracker command, which you can use to change that number without using a 𝚂𝚘𝚋𝚘𝚙. So I can clear it, and now if I get my level, it's 0. Or I can set it back to 4, and then the next time I activate a shrieker, another warden will spawn. I regret to inform you that if you're drinking an ominous bottle and waiting for the raid omen effect to end, then you are a level 1 noob. You see, I'm a level 100 hacker, which means I use the raid command to start a raid instantly. I can also do raid set omen to increase the difficulty of the raid. I can do raid check to check that there's a raid here. I can do raid spawn leader, which spawns a leader illager. Raid glow makes all the illagers glow. And raid stop stops the raid entirely. There's also a wacky one called raid sound, which requires a type, but the only type that actually does something is local. And when you run this, you can just barely hear a raid horn, which it plays 5 blocks away from you on the x-axis. The last command is probably the most interesting one. It's test with a whole bunch of options. This is Mojang's unit testing system. When developing software, a programmer might want to take small units of their code and run automatic, isolated tests on them. It can be as simple as simulating a button getting clicked and checking to see if it did anything. Minecraft has its own custom system where they literally spawn in a bunch of mini structures that test a single game mechanic or interaction. What you're seeing is a clip from a talk by former Mojang employee Henrik Kniberg. If you're interested, there's a link to the full talk in the description. While I don't have access to all the tests they have in that video, with the test command, I can make my own. So let's make a test for powder snow being dispensed by dispenser. What I can do is test create, then let's call it powder snow dispenser. Let's make it 3 by 3 by 3. And when I run this, it'll create a little setup. Now what I can do is build the setup. To save this, do not use the structure block. Instead, do /test export closest. To add this to my mod, I'll go to my Minecraft folder, find the game test structures folder, take this and add this to my mod's data pack. Now comes the scary part. You have to code this test in Java. Don't worry though, they actually make it quite easy. So in this class for our tests, we have a method annotated with the name of the structure we saved. In here, I can write out the test. We can use this context to interact with the world. So let's go back into the world and see what we need to do. All right, we'll need the context to press this button and then detects that this block is powder snow. However, there's a problem. It doesn't know where this button is. It's not as simple as typing in the coordinates of this button. If we place this test elsewhere in the world, the coordinates of this button will change. Thankfully, because this is a structure, we can get coordinates relative to this corner. And of course, there's a command to help us with this. We can do test pose, and that'll tell us where this is relative to this corner. So this is at 1, 2, 0. The powder snow is at 1, 3, 1. Back to the code, we can have the context push a button at 1, 2, 0. Then the context can expect a block. The block is powder snow, and it's checking at 1, 3, 1. All right, I'm gonna relaunch my mod with this code and it should all be working. Okay, let's test it out. So I can go over here, do /test, run, and yep, I have an option for the mod's test. And let's see. What? It failed. It expected powder snow, got air, but there is powder snow. Well, that's fine. I can show off what happens when it fails. You can see there's a beacon that shows you the status. In this case, it's red because it failed. This lectern has a book and quill that tells you exactly what went wrong. And there's even a red box being rendered telling you what it expected. All right, I figured out what I did wrong. Instead of doing expect block, I should have done expect block at end. Of course, rookie mistake. Okay, now if I try it again, yay! It worked. While this was a simple demo, hopefully you can see how this could be really useful for developers. If you're at Mojang working on a snapshot and you change a feature, you can run all their automatic tests and see if you accidentally broke anything. Well, now that I'm done with this, I can do /test clear all, and it will remove it. In Java Edition, when you press F3, you get the debug menu with its lines that span more than half the screen, which you love to see. You might also know that if you press F3 and another key at the same time, like F3B, you get some hidden tools. In this case, I can see hitboxes. Well, wouldn't you know it, there are some hidden F3 key combos, which my mod makes accessible. A lot of these have to do with how the world renders. So first of all, there's F3E, which shows you the section paths. While I'm not entirely sure what this is, I do know that these points are the center of a chunk section, which is a 16 by 16 by 16 area. And it seems like they get more green the further away from you they are. I am certain this is ruining the bitrate, so I'm gonna turn this off with F3E again. And moving on, there's F3L, which disables the smart cull. This again has something to do with rendering, and it definitely impacts performance. Notice how if I reload chunks, you can see all the chunks popping in quite slowly. Now I'm going to do F3L again to re-enable smart cull, reload the chunks, and it's near instant. Next, when I press F3 and U, ooh, what is this? We get a massive shape called a frustum, which encompasses everything that was in view when I pressed the keys. If I press F3 and U again, you can see it moves, and this little rectangle takes up where my camera was. Everything that lies beyond this shape is culled, or it is not rendered. This is an optimization technique called frustum culling, which prevents everything you can't see from rendering. The frustum is also responsive to your FOV, so if I turn it all the way down and then capture my frustum, you'll see it's quite pointy, and if I turn my FOV all the way up and capture it, you'll see it creates quite a broad shape. And then to disable it, I can hold shift and then do F3U. There's F3V, which shows section visibility. Now, rendering is not my strong suit, so I'm not entirely sure what this is doing, but I know for certain it has to do with optimization. I think these red lines point to other sections based on some sort of metric. You can see underground, you have these very interconnected red shapes. Last and definitely least is F3W, which claims to enable a wireframe, but it actually doesn't. As a matter of fact, in code, it changes a value that's not checked anywhere. This must be a discontinued feature. Let's move on to the final and most diverse set of developer tools, debug renderers. Because there's a lot of them, I helped myself out and added a custom F3 key combo, F3, F6, which opens a custom menu where I can enable and disable all these debug renderers individually. Only 2 of the debug renderers were completely functional by default, and that is the chunk border renderer, which is in vanilla, and you can get it by pressing F3 and G. And the box you get with test pose with text on top, that is also a debug renderer that's enabled by default. However, the rest I had to repair. The game had instances of all these debug renderers, but it didn't tell them to render, so that was the first fix I did. I told them to render, and that got some of them to be fully working. Regarding the rest, well, how do I put this? Minecraft runs in two environments, the client and the server. When you join a Minecraft server, your computer is running the client. There's information that the client knows and the server doesn't, and there's information that the server knows but the client doesn't. However, they can tell each other this information by sending packets. This is where the difficulty lies. Even when I'm in single player, the game simulates a client as well as a server. This means your game has to send packets to itself to work. So some of these debug renderers are functioning off of information that only the server knows, which means I need to send packets so that my client knows this information and can render it. The good news is that the game already has a packet that handles debug payloads, which inform the debug renderers. As a matter of fact, the game even tries to send this information. For example, the bee tries to send its information every game tick. However, when it comes to filling out and sending these payloads, the code is missing. So what I've done is put together these payloads and make the server actually send them. There's almost no documentation on how these payloads are supposed to be assembled, so it's possible that some of these debug renderers are running on the wrong information. Regardless, I think I did a good enough job, so let's finally get into these debug renderers. First off is water, which represents the fluid level of water with a number. So if I were to place water that pours, you can see that this is 8, this is 7, and down here we got 6, 5, 4, 3, 2, 1. It also looks really cool as you approach an ocean. Check that out. The neighbor update renderer shows you the amount of neighbor updates that happened in an instant over the course of 10 seconds. So once 10 seconds pass, these will go away. If you didn't know, neighbor updates are the system that allow blocks to have chain reactions with one another. Normally, a block will send 6 neighbor updates to the blocks around it. However, redstone is interesting. It sends an extra set of neighbor updates above it, and when I break it, it sends even more neighbor updates. You can see in an instant, 6 neighbor updates happened where the block was. Now I understand why Mojang has an experimental toggle in the latest snapshot, which reduces the neighbor updates redstone sends. I mean, just check this out. With a few pieces of redstone, if I power and unpower them, we're getting 65 updates in an instant? That's crazy. I understand why people can crash servers just by powering a field of redstone. If you've heard the term quasi-connectivity and were confused by what it was, this renderer can help explain what it is. Okay, one second, I have to wait for these to go away. Quasi-connectivity is a bug-turned feature whereby pistons, droppers, and dispensers can be powered normally from a block to the side, or they can be powered by powering this block above them. However, powering this block, as you can see, does not send a neighbor update into the piston. Therefore, the piston needs to be updated somehow so it realizes that it's powered. Now, when redstone is powered, it sends an update 2 blocks out, so if we power this redstone next to the piston, it'll extend. The height map renderer shows you the highest point with different height maps. Minecraft uses height maps to quickly find out the highest point at a given location. You can see there's different colors, so this teal is considered motion blocking, and the green is considered world surface. Motion blocking ignores blocks like grass, which you can walk through, but world surface takes them into account. When I place a block, 2 more height maps come into play. This dark blue is considered ocean floor, and this cyan is considered motion blocking no leaves, so you can see it goes right through the leaves. On the other hand, ocean floor will sink to the bottom of the ocean. Next up, we have Brain POI Village, which covers, well, brains and POIs, or points of interest. This baby villager has a whole bunch of text above it. That is the brain debug renderer showing you what's going on in the baby villager's brain. Meanwhile, this horse and pig don't have anything. That's because they don't have brains. No, seriously, in Minecraft there's 2 different ways mobs can have AI. Either they use this brain system or they use a goal system, and actually there is another debug renderer for goals. So let's dissect the brain of this villager. The villager's profession is farmer, they have 0 XP, 20 health, they have a potato in their inventory. With the brain system, a mob has a set of activities that then determines their tasks. So in this villager's case, their activities are work and core, which then determine the fact that they're doing the random task, move to target task, and look around task. All this gray text above them are the memories that their brains can have. Some of them don't have any info, some some of them do have info. These memories play a role in determining how villagers perform their tasks. If I unfreeze the ticking, punch this villager, and freeze it again, you can see the villager's gossip values. For example, I have a minor negative gossip of 25 after punching this guy. And in case you couldn't tell, this also shows the path that a mob is following. That's what these blue and red rectangles are, and the green is their target. Villagers aren't the only mobs with brains. Armadillos have them too, alongside frogs, goats, sniffers, camels, axolotls, allays, breezes, piglins, piglin brutes, hoglins, zoglins, tadpoles for some reason, and wardens. Now, wardens are interesting because they have their own anger level value. If I were to send them a vibration, you can see their anger level increases. This brain renderer will also ruin the illusion for you. You've been told that wardens are blind, but clearly they have a nearest visible player memory. Not so blind after all. The last feature of this debug renderer is the point of interest renderer, which shows you points of interest and the values that pertain to them. In this case, the head of a bed is a home point of interest. This bed has 1 free ticket. This bed has none because it's claimed by Sneak Hair. Yeah, Minecraft has a name generator. We'll get into that in a minute with the B debug renderer. Lots of different blocks are different points of interest, including nether portals. The B debug renderer has a bunch of B specific information like their goals, the position of the flower they're after, their hive, and also a randomly generated name. Any flower they're seeking out is highlighted with the names of bees that are looking for it, and their hive is also highlighted with the names of bees that'll return to it. I'd imagine they'd be using this debug renderer to tweak the behavior of bees so they can properly pollinate. As you saw, poor 𝚂𝚘𝚋𝚗𝚋 had a bit of trouble, so maybe they need some more tweaks. And regarding these names, Minecraft has a built-in tool that can turn an entity's ID into a name composed of a randomly picked prefix and suffix. Here are the prefixes and here are the suffixes. Comment below what your random Minecraft name would be. Mine is 𝚂𝚘𝚗𝚘. The collision debug renderer shows you the collision shape of the blocks around you. The collision shape is different than the outline shape, like this gray outline on the grass, because collision shape is, well, what you collide with. What's interesting about this is it shows you the individual voxel shapes that come together to make the entire collision shape of a block. Here we can see 2 different voxel shapes that compose these stairs. Or with fences, we can see that the collision shape actually goes half a block higher than the outline shape. And as I stand on the fences, yep, it looks accurate. With fence gates, when you open them, the collision shape goes away because you can walk through them. This debug renderer also shows some interesting quirks with voxel shapes. When I turn the renderer on, how many voxel shapes do you think compose the collision shape of this azalea? If your guess is 2, with 1 for the stem and 1 for the leaves, then you're incorrect, it's 5. My guess with what's going on here is that the algorithm that figures out the voxel shapes calculates from the bottom up. So it starts with the stem and it continues it all the way up to this square at the top, and now it's left with an O shape around it that it has to turn into rectangular prisms. And so this is the best pattern it can follow. This issue is also noticeable on anvils, cauldrons, and hoppers. Look at how many shapes make up a hopper. That's crazy. Another interesting thing about this renderer is it takes your player into context. So this scaffolding does not look like it has a collision. However, when I'm above the block, it does. But if I sneak, it no longer has a collision. This pretty much reveals how scaffolding works. When you're above it, it gets a collision. But when you sneak, the collision goes away and it behaves like a ladder. It's a little hard to see, but the same thing happens with powder snow. When I'm above it and I put on boots, it gets a collision, but if I'm sneaking or below it, it doesn't. The pathfinding debug renderer shows you a visual for paths similar to that of the brain and B debug renderer. However, this one shows you what type of pathfinding node each block is. So over here, I have a pig that cannot cross over the magma because it's danger fire. Skylight shows you, well, the skylight at a given position. So it goes from 15, where it doesn't render, all the way down to 0 in this cave. If you're curious about these big numbers, 0 means that a chunk section has blocks, 1 means a chunk section has light data, and 2 means that there is no light data or blocks in a chunk section. I'll also enable light because it's fairly similar. You can see outside these gray areas is 2, inside is 1, and inside these yellow areas is 0. Game event shows you where game event listeners are, like skulk sensors, renders a box around them, and annotates any game event that happens inside. So my footsteps make a step game event, or breaking a block is a block destroy event. Skulk sensors, calibrated skulk sensors, skulk catalysts, and skulk shriekers are all blocks with game event listeners. The warden has a game event listener at its position, and even alleys have a game event listener for note blocks. Also, check out how many flap game events an alley makes. Village sections had no sign as to what it does. It just contained a set of chunk section positions where where it renders green cubes, so I just fed in every chunk section which contained a village. Hopefully that works. Breeze shows special data that pertains to breezes. I'll have to go into survival for this one, but you can see a circle renders around me. There's a line that points to me, and when this breeze jumps, a red box renders at their jump target. This circle around me has 3 zones. There's a green zone that I'm in, a orange zone, and a red zone all the way back there. It seems like when the breeze jumps around, it tries and stay between the green zone and the orange zone. You can see when I get up close to it, it tries to run away into this section. Raid center shows the center of a raid, so if I start a raid, you can see it shows the center. This is the position that all the illagers will gravitate towards. Goal shows you the goals of a mob, with the green one being the one that they are currently doing. If I get an evoker in here and dye the sheep blue, you can see it's doing the look at target or Wooloo goal. Sorry, I just wanted to point out that there's an entire goal dedicated to Wooloo. Supporting block renders a cube slightly larger than the block you're standing on, as well as the collision shape of the block you're standing on with colors that go from red to yellow. I'm not really sure what this is for. Maybe it's for detecting the block you're standing on even when your center's not above it. Chunk loading shows you the status of all the chunks around you. Minecraft full means that the chunk is done generating, and entity ticking means that entities will, well, tick. If I start flying really fast to generate new chunks, you'll see that these chunk statuses have different colors. Unfortunately, they go away too fast for them to really be red. However, this pattern might seem familiar. Ooh, a mushroom island. When you make a new world, these pixels represent the chunks around you, and the color represents which step it is. So this debug renderer is just a in-game visualization of that. Structure renders the bounding boxes of individual structure pieces, as well as a large white bounding box for the entire structure. In this village, this green structure piece is the origin that all the other pieces stem off of. You'll also notice these empty pillars in the town center. These are structure pieces that contained a villager. I can run this command to spawn in the exact piece with the villager. This is what a sprawling mineshaft looks like with this debug renderer. This is what a trial chamber looks like. Notice how every single pot is its own structure piece. Interestingly, this intersection room is not the origin. It's actually this room over here. Where's the bounding box for this shipwreck? Why, it's all the way up here. I guess the shipwreck structure piece is placed up in the air, and then when the blocks are placed into the world, gravity does its job and it goes to the sea floor. It's a similar case for ocean ruins, and this single floating green cube is actually buried treasure. Even though it's buried, you can get a feel for how the trail ruins generate based on these bounding boxes. Here's what an ancient city looks like. Here's a stronghold. Notice how this dungeon does not have a bounding box. That's because it's a feature and not a structure. Here's a bastion, and check out this end city. This looks really cool. Block outline renders all solid block faces in red. In other words, this is a debug renderer that shows you where you can place buttons. For example, the face of this door is red, therefore I can put buttons on it, but if I open it, then these faces are red, so I can put buttons here. Last and definitely least is World Gen Attempt. Again, I had no clue what this did. It was just a list of colored boxes, so I made it place a white box in every single chunk. And because I had nothing else to do with this, I also made blocks change color when you click on them with a dye. I'm sure some of you have been wanting me to turn everything on at once, so let's do it. First, I'll do the F3 key combo, so E, U, L, V, W, and now debug renderers. My frame rate is definitely dropping. All right, here you go. This is what it looks like with everything enabled. Well, if there's one thing that I've learned, it's that more goes into making Minecraft than meets the eye. If you want this mod, my Ko-Fi supporters got it early, but I'm releasing it publicly now. Link is in the description.